Well, hey everybody, how are we doing? We're getting to the end of our first real chapter here in algebra. Of course, this being a middle school algebra class, we had to fast forward a bit and teach us some exponents here. So as we sit here and we look at this, these are dealing with everything from section 2 to section 4, all the different rules that come into place. And this time what we're dealing with is we're going back and we're looking at exponents that with fractions. These are also sometimes called radical exponents, not because they're cool, but because they can be converted into a radical form or a square root or a root of some sort. So we're going to learn how to do that today. It's like kind of our first translation formula of the year. So sometimes you're going to see that exponents are fractions. And again, don't be freaked out by fractions, guys. Please, please, please. We know how to deal with fractions. We've been doing it for a very long time. It's super simple. We just work with them, and then we deal with them, and we follow the directions which they give us for our problems. Here's what it might look like. You'll see right here. Okay, we have an x to the 1/2 power. We'll work with them exactly the same way and sometimes have to, again, convert them to a radical form. As you see here, here's our first example. We have to just stop and look and see, well, what are we doing? And if we look at this, look, we have an x to the 1/3 power sitting right next to an x to the 3/4 power. This is multiplication. Of course, I also have it written here, multiplication. So we follow the same rules from 7-2. Base stays the same. Add your exponents. So in this case, look, you're going to see the base is going to stay the same. And maybe in the homework, they may have a like x to the a. They want you to fill in, well, what is the a going to be? So base stays the same. There's your x. We have to do what? We have to add these two things together. So remember when we have fractions and we are trying to add two fractions together, we must have a common denominator in order to do so. Here, look, my one denominator is a 3, one denominator is a 4. We have to make these be the same. Okay, there's nothing I can multiply 4 by that'll turn it to 3. Nothing I can multiply 3 by that'll turn it to 4. So I have to find a common denominator between 3 and 4, and I think it's 12. So that means I have to multiply this side by 3/3. Because honestly, what 3/3 is 1. So I'm really multiplying this by 1. Or I'm expanding the fraction. I'm making the fraction bigger. You're algebraically manipulating it. That's why I said fractions are easy. If they're not what we want, we know the rules on how to change these. Well, how do I get this one to a 12? I multiply this by 4/1. Okay, so 4/4 times 1/3 plus 3/4 times 3/3. Notice it's 1, it's 1. Let's do this. Well, 4 times 1 is going to be a 4/12. And then we have what? 9/12. And so now that we have the same denominator, we can just add the numerators. 9 plus 4 is 13. So what would we plug in our blank? We would plug in our blank would be 13/12. So that's x raised to the 13/12 power. Notice that fraction cannot reduce, so we are good to go and move on. Next one. Look, what do we have here? We have a x or a base. There's a base that's being raised to a power in a set of parentheses with a power outside. That should indicate power to power rule. So remember, power to power rule stated we are going to keep the base the same, and then we have to multiply these exponents together. That's no big deal. We know how to multiply fractions. 2 over 3 times 1/2. All we do is multiply the numerator, multiply the denominator, simplify if we have to. So this is what, 2 over 6. This can reduce. 2 goes into 2 once. 2 goes into 6 3 times. So our answer, total answer, is x to the 1/3 power. All right. I mean, that was some hard math there, right? I think we learned how to start to do that in what, 4th grade, maybe 5th grade, probably 4th grade. If you're just applying our rule to something that has a fraction. What we're going to learn next is, this is like really something that's totally new, is how do we convert this? Because, you know, this is actually something, there's something hiding in this that we don't even know about. We've seen these root symbols before, okay? Here's a root. It's a root button. It's the check mark looking thing. And we have different roots. We have square roots. We have third roots, fourth roots, eighth roots. So the N designates, this is called an index here, the index. Or what root is it? What root is it? The index is there. Everything under here is called the radicand. And this thing here, that is the radical, or the root symbol, okay? Now, it's pretty easy. Notice that there's an n in here, there's an a, and there's an x, and it equals a to the x over n power. So pretty much all we have to do with this is that we'll reduce something to say like this right here. If we were going to convert this here, well, we have our symbol, the big letter here. And normally they're going to try not to use x's, but so here's your big letter, the unknown, the variable. Now we look at the numerator of the fraction. We look at this. So the numerator of the fraction here is what we raise the radicand to. So we're going to raise this to the power of 1. You don't always write that though, okay? And then we look, well, the denominator in the fraction, the denominator of the fraction is n, and the n is the index. So that's a 3. So this is the third root of x. That's how we convert. This and this is the same. Okay, that's like an extra bonus, doing it twice. So we have to just be careful when we do these. And they're going to give it to us in a couple of ways. Maybe we have to just nice straightforward. So here is this symbol. Okay, they want us to translate this or convert this into radical form. So I know I'm going to need the radical symbol. All right, and here is my base. Is this little hourglass? Great. Now, the numerator, look, the numerator here is what we raise that base to. If there's a number, there is a number here. So this is the 3. See, it looks just like this. We're looking at this. This here looks like this. So the x is in the numerators, and it's what goes inside, raises that inside radicand to. So, all right. The denominator is the index. So it's a square root. Now, here's the only thing that we have to be careful about. Yes, I know that we go 2 here. Anytime you see this symbol and it doesn't have a number right there, it's a given. That's just one of those given things in life. It's a square root. We do not always have to type that square root in, so be careful. If you're doing a problem in the computer and they have you may not need to type that in. If they give you 2 options in your box to input, if there is a square root, or sometimes they'll have one that looks like this with a little box. This is the one, it's a specific one specifically for 2. This is for anything other than 2. So you would type the number in if it's 3, 4, 5, 6, or so on. Okay? So if you have a 2, generally there's going to be a special one for just 2. So we wouldn't have to write the 2 there. Okay? Anything other than 2, they're going to give you this new symbol here, and that lets you input an index in there. Okay? Other than that, when you go to type the radicand in, you would just hit the Shift 6 like normal to add an exponent if you had to. So again, this here, I gotta reduce, this line is a little thick. This here is your final answer for that. It's the symbol raised to the 3rd power, and of course we don't need to have an index because that is a square root. And you'll notice that sometimes when Mr. C writes them, see how I do this? And I like drop a little tail. And that's why, so I know exactly what's included underneath this symbol. This is a grouping symbol, sort of, so we need to make sure that we know what's supposed to be in it. Because if we don't want to make sure we accidentally include something that shouldn't be. All right, so we have this going on here for our next example. And notice, for right now, if you don't even worry about this root symbol, okay? Don't even worry about the root symbol right now. All we want to do is we want to look at this. We want to look at what's inside of this grouping symbol, and let's reduce it first. So I have z to the 2nd power divided by z to the -4 power. And this is division of powers. Which one is bigger, -2 or -4? Think about that on a number line. You have a number line, so 0, -1, -2, and then -4. So we're going to do all of our math up here in the numerator. So we have a z to the -2 power minus a -4. Keep, change, change. So -2 plus 4 equals a +2. Now we can carry on all that other stuff we have going on. Now what we want to do is, this is another conversion problem. So we're going from a root back to a radical, the radical exponent, the fractional exponent. Right, so our base inside here is a z. And now we have to create this fraction outside. So look, the little x here is what the radicand is being raised to. What is the radicand being raised to? A power of 2. Sorry about the alarm. So here we see that, again, the radicand is being raised to a power of 2, so the 2 goes in the numerator. The index of the radical is 8, so the 8 goes in the denominator. So this is z raised to the 2/8 power. Hopefully someone's like, oh, wait, Mr. C, this is not reduced. That's right, it's not reduced. You can reduce that fraction. So 8 and 2 goes into 2 once, and 2 goes into 8 4 times. So z to the 1/4 power, and that would be your final answer if they're asking you to convert it back and forth. So it's not really hard, guys. This is just something we need to be able to write down. It isn't something that's super special. It's just a little memory trick. Drop it on your paper the day of a test. You may now begin your test. Boom, that's going to be one of the formulas that we will memorize, and we just drop down. Another way that I help memorize this is, think of this, the square root of x. So this is another way we can do it, right? This here, the top piece is your 1. The 2 says this is a square root. So I use this sometimes to help me remember this formula. And then I can just think of it back and forth. This is all right. So what the numerator is what the inside is being raised to. The denominator is the index of the radical. Either way, whatever works for you. Okay, I'm going to erase that so we don't. Okay, let's look at some more examples here. All right, so here we have a fractions inside of with powers being raised to power. This is power to power rule. We have to be careful. We need to simplify what's inside this first. So this is multiplying. Multiplying says we have to add these two things together. So a -3 plus 6 is c to the third power. And this is all being raised to the power of 5/3. All right, we have to apply the power to power rule. So 1 multiplied any amount of times is still going to be 1. And power to power here is we need to multiply these two exponents together. So 3 times 5/3. So 3 times 5/3 equals what? 15/3. What is 15/3? I'm doing side work here. Okay, side work because I'm multiplying these two here together. So 15 divided by 3 is not 3. 5. 3 goes into 3 once. 3 goes into 15 5 times. So I end up with here 1 over c to the 5th power. All right. I'm be careful because maybe if they give us something like this, they may say write an equivalent expression. So we'd have to pick our answer out of the bunch. Next, we're going to have simplify and convert our answer. So we have to look at this. So first off, let's look at what's going on in here. We have multiplication of two like variables. Remember, that's a power of 1. Our rule from this was from 7.2. Said we multiply bases that are the same, we add the exponents. So so 5 plus 1 is 6. And now they want us to convert that. So remember our conversion, okay? If we have to convert this, we're looking, if this is here, this n tells us here, this is going to be, again, bad use of variables. I didn't pick these. I'll change this to a W so we can see it. Right? We have to take the base is n, and whatever that radicand or the inside piece is being raised to the power of, that becomes our numerator. So this is what, 6. And the index is the denominator. And then all we have to do is reduce that little fraction. So 4 does not go into 6 evenly, but 2 does. So 2 goes into 4 twice. And 2 goes into 6 3 times. That wasn't so bad. This is the piece we have to get used to here. being able to convert from a radical form to an exponential form. And then we have two mixed practice here. These will be what the last couple problems are. Again, this is blending several rules together. We've been doing some of these. This time we're blending power to power, multiplication, and division. So when we look at this, we have parentheses. That's what we should be doing first. So this is the power to power rule. So when we look at this, again, that's a big number. 3 raised to the power of 5. 3 raised to the power of 5. 243 we get. All right, so we have 243 Z. And then this is power to power, so base stays the same. We multiply our exponents. 10. All right, now we have exactly what we did. This is from 7-4. Division. So we have to say, does 15 go into 243 evenly? I'm going to say no, because look at the end number. It's a 3. If it went in evenly, it would have to. This would end in a 5 or a 0. So let's look at other numbers that make up 15. We have what? 3 and 5. So does 3 go into that evenly? 243 divided by 3 is 81. So this is 81. And 3 goes into 15 5 times. Now we look at these two here, and we should say, do we have a Z in the numerator and the denominator? Yes. Where is that exponent bigger? Upstairs in the denominator. And so we subtract. 10 minus 5 is 5. There's our final answer. We just mixing things up. And now this one, I know it's going to look so confusing because we all have all these negative symbols and all this fun stuff. Just deal with what's inside the parentheses first. We start looking, so we have a 6 and a 3 on the outside. We can know that right there we should see reduces. 6 divided by 3 is 2. We have to do the power to power rule. All right, so we have to multiply the exponents. So -1 times a -1 becomes a +1. Y to the -2 power. So -1 times that comes y to the 2nd power. Now we can tackle the rest of this because we took care of these. Maybe you're looking at this and says, ooh, this isn't supposed to be here. I need to send this upstairs. Okay, so do it. Because we're trying to get rid of that negative exponent. Well, now I have multiplication going on up here. And this is going to be probably our final. So let's deal with these y's. So y to the 2nd times y to the 1st. You add the exponents. Add these together. We get y to the 3rd. And we're dividing. And the bigger exponent is down here. So we do all of our work for x downstairs. 10 minus 1 is 9. And like that, we have finished up all that we currently need to know about exponents. All right, guys, you're going to notice your homework today is in Delta Math. Please go and try to do your best on it. It is, again, dealing with the radicals is the new part, and then a couple of questions on the mixed review. Tomorrow we'll start our review for our first test in algebra. All right, guys, have a great one.